Welcome to another number talk from me, Super Teacher Guy Sean Bird, and visualpatterns.org. This is puzzle number 123. It's a really good puzzle to see equations in a really unique way. So without any further ado, let's get started. We have the first three iterations. We have the first three rows in our table. As usual, let's begin by just counting up the number of, in this case, blue dots. In the first iteration, there are 4. In the second iteration, there are already quite a bit more. I'm going to count them as 4 plus 4 plus 4, so 4, 8, 12. And then in the third iteration, it's already, again, a lot, but I can see it's 3 by 5, that's 15, plus 9, that's 24. Now, as a student trying to figure out the fourth iteration, I would look at the table maybe and try and decide it's growing. They're always even numbers, but the growing pattern here, it goes up 8 from iteration 1 to iteration 2. Then it goes up by 12 from iteration 2 to iteration 3. So I know it's not linear growth. There's no constant rate of change here. It's increasing. It's making this parabolic curve upward. So I'm thinking that 8 to 12, well, that's a change of 4. So maybe I would go up 8, 12. It's possible it's going to be 16 more because that's the change of 4. And 24 plus 16 is 40. But let's see if that bears out as we think about the pattern in a visual way. So let's see. Iteration 1, there are 4 pieces. Iteration 2, it's a bit easier to see this idea of squares, right? Because there's also definitely symmetry here. But I see squares in the middle, 2 by 2. And here I see squares of 3 by 3. And I know how to find the area of a square. And then on the edges, there's the iteration number, which is another pattern that I think is helpful. I'm going to use that pattern and look here. Well, this could be a square. It's just 1 by 1 is 1. And there are 2 of those. So that's definitely a growing pattern where I can see this is a length and width of 1, but twice. This is a length and width of 2, but twice. This is a length and width of 3, but twice. So over here, I can assume there's going to be a length and width of 4, but twice. And so that's 16 plus 16. And then there's like the iteration number hanging out on the sides twice. So I'm going to use that as orange. I'm going to put an orange here and orange here, and it's going to be 4 and 4. Just like here, it's 3, 2 groups of 3, 2 groups of 2, and 2 groups of 1. So let's add this up. 16 plus 16 is 32, plus 4 is 8. 32 plus 8 is 40. So that works. And so now that we have that idea, we could probably even use that for the 15th iteration. So let's think about that. It's going to be 15 by 15. I'm going to write it in red. I'll put it over here. It's 15 by 15 twice, and then 2 stacks of 15 on the left and the right. So 15 squared, I know, is 225. 15 times 15 is 225. So 225 twice, that equals 450. Plus 15 is 30. So 450 plus 30 is 480. That is the number of blue squares that will be in the 15th iteration. So now let's talk about in terms of x. For any iteration, how can I figure out the y? That's the equation that I've been hinting at least one way to write the equation for the last couple of minutes. I'm going to erase this so we can write out the actual equation. So let's do that, at least try. Okay, I'm going to use red for the squares, and it's the iteration number as a square. So for example, any of them, it's x times x. So x times x is the area of the square, and there's two of them. So I could even use brackets like this. So it's 2 length times width plus these two outside iteration numbers hanging out. So it'd be plus x. That is one way to write the expression for this information, but I can simplify it. X times x is x squared, and then 2x squared can be written as 2x squared. And then plus x, that's 2x's, so plus 2x. That is actually a more efficient way of writing the equation for this table and for this visual pattern. Y equals 2x squared plus 2x. But wait, there's more. Another related way to see this equation is to see not two squares, but one longer, taller rectangle. What I mean by that is here, this is a rectangle of 2 by 1. This is a rectangle of 4 by 2. This is a rectangle of 3 by 6. So can we see the relationship that this height is always twice as much as this width, and this width is always the iteration number. So as an expression, I could write it x times 2x, because 6 is twice 3. That's for the area of the rectangle, so I'm going to put that in brackets. Plus, you have x twice, so still plus 2x. So this is another way of writing the same equation, and then x times 2x is, if you rearrange it, it's equivalent to 2x squared. So these two equations are sort of two ways of seeing the same thing. I hope that makes sense. If you need to, now would be a good time to pause the video and compare this idea to when we initially figured out this equation, and you'll see how they relate. So this was, again, puzzle 123. If you feel so inclined, you should graph it. If you haven't done so yet, you should try the Desmos graphing calculator. It's a great way to see equations, and you can type in both of these, and they should give you the same looking graph. It should be a parabola. I hope you learned something today. Please watch my other number talk videos using visualpatterns.org. I have a growing library of them, so you can look at them once a week or once every couple of days to get your kids, or to get you, used to talking about growing patterns as equations and as data tables. Thank you, and have a great day.